Hi, my name is Connor Carreras, and I'm a solutions engineer at Firebolt. And today we are going to talk about data ingestion. So at a basic level, data ingestion is all about getting data from a source system into Firebolt, and doing this will enable fast querying. So this involves naturally connecting to your source system and then extracting data from it and writing it into the Firebolt storage layer as trickle files. Now, you could also use Firebolt, technically, as a query engine on top of externally managed data. So this could be data that exists in your data lake already. But if you're really looking to support those low latency, high concurrency use cases, the best performance in Firebolt will always come from putting data into Firebolt's managed storage layer. So there's typically two types of ingestion that you're going to be dealing with. The first is what we call bulk ingestion. So this is when you're doing a massive data load. We're talking like multiple gigabytes, terabytes, potentially petabytes of data being loaded into Firebolt at a single go. Typically, the requirements for this are you need to get that done quickly and cost effectively. The other type of ingestion is called trickle ingestion. So this is more common in near real-time use cases where you're loading small quantities of data very quickly into the system. All right, so now that you know ingestion at a high level, let's look at how ingestion works in general. So as I said, all data in Firebolt needs to be ingested into a table. So a table consists of rows and columns, and as I said earlier, it's backed by a file in trickle. Now, the starting point for ingestion in Firebolt is going to be your object storage. So we're going to have this be our S3 layer. And you've got a bunch of files in S3. So I'm going to draw some files as these little squares. Let's see, we've got 4 files. So when you set up ingestion in Firebolt, the very first phase of this is reading from S3. Read from S3. So each of these files gets read. And then in the next phase, what Firebolt is going to do is actually turn this into columnar data. So we're going to call this create column data. So this is all a multi-stage ingest. So what that means is that as different files are being streamed from the source and entering each of these stages, you can have files at different stages of this process all being ingested kind of in parallel. The next step is optimizing. So this is specifically optimizing tablets. So tablets are the actual unit that comprises a trickle file. So these have chunks of data that's sorted and organized. We'll get more into that in a following video. So again, we're taking those files, we're optimizing the tablets. And then finally, after you've got your ideally structured tablets, we're then upload to S3. So this is moving the data from where it's being processed currently in the RAM of the engines that are doing the ingestion, and then being put into the remote file storage in Firebolt. And that ultimately becomes our trickle file. Ta-da! All right, so one of the really cool things about ingestion in Firebolt is if your engine has multiple nodes, the ingestion can actually scale linearly across the nodes and process different files at the same time. So looking at our 4 files in S3, if we have, say, a 2-node Firebolt engine, node 1 might grab these 2, and node 2 might grab these 2. And then we're going to repeat this entire end-to-end process in parallel on 2 nodes, and it'll take half as long. Now that you understand how ingestion works, let's talk specifically about how to ingest data into Firebolt. So there's 2 methods for bulk ingestion. The first is copy from, and the second is insert into. And this is specifically working with an external table. So let's see how this works. So we're going to start with copy into. So copy into is going to take a raw file on S3, read it directly, and then insert all of that data into a Firebolt managed table. The copy into syntax is pretty straightforward. You can see it here on the screen. We are naming the table that we're creating. We're specifying the location on S3 where that data lives. and any of the credentials that we need to access that data. I'm also telling Firebolt that this is a set of Parquet files. Now, one thing that you'll notice is that as part of this copy into, I haven't first run a create table statement. So copy into is pretty special because it has automatic schema inference. So these are Parquet files, they're well structured, they have data types built into them, and so I can just read those Parquet files directly and create the schema based on what has been defined inside the Parquet file. So if I run this ingestion, you can see that this is executing pretty quickly. It's a relatively small data set, but if I go in now and query, select star from agents, limit 10, you can see that I've now got data in this table. So the second method to ingest data into Firebolt is by using insert into coupled with an external table. Now, an external table is not frequently used as the way to ingest data. We typically see this if you have JSON data, or maybe if you want to do any sort of transformations as part of that ingestion. So there's not necessarily a one-to-one mapping between how the data looks in S3 and how you want it to be materialized inside of Firebolt. So by creating an external table, I'm essentially making a pointer to the raw data on S3, but I'm not transferring it into Firebolt. So the external table syntax does define each of the column names and data types. It again points to the location of the file on S3, specifies the credentials, the pattern, and the type of the file. So when I run this, you'll see we now have an external table. Now, external tables are going to be slower. So I can query this table, select star from EX agents. Let's put that limit 10 in again. And you can see this takes a little bit more time than that same query on the internal data took. Again, this is because Firebolt is operating in this case as a federated query engine. We're just reading the data from the files on S3. There's no Firebolt specific optimizations that we've done on the storage layer. Now let's say I want to get that data from S3 into Firebolt. I can read all of the data directly from that external file and insert it into my managed table. So I already created the managed table. I did that as part of the copy into, but if I hadn't run that previously, you would need to also run a create table statement before doing this insert into. Insert into doesn't automatically create schemas. So I can run this command, and again, we now have more data in our table. So those are the two methods for batch ingestion. I did talk earlier about the other type of ingestion, trickle ingestion. So if you look at the screen, we've set up another insert into command. In this case, we've specified different values that are being inserted into our table. So we're going to insert 3 records at once. I'll go ahead and run this. So you can see it's still pretty fast in Firebolt to do these small trickle ingestion patterns, or in this case, just 3 records. Now, in general, you can run trickle ingestion with just 1 value. However, it's not necessarily going to be the most effective way to do your ingestion. If possible, we recommend batching a lot of these sets of values into a single statement. So potentially instead of 1 or 2 or 3 records at once, maybe up that to a few thousand. The reason you want to do this is so that when the ingestion happens, Firebolt ensures that you don't have very tiny tablets created in the storage layer. So now you've had a quick overview of ingestion in Firebolt. You've learned about a few different high-level ingestion patterns. You've seen how ingestion actually works behind the scenes, and you've gotten a demo for a few different methods for actually getting data from S3 and into Firebolt. Thanks for joining us.